All right, hello, good morning. Yeah, let's just dive right into it. I'm kind of tired of doing the summary every time. So let's just dive into where we were last time. So we were looking into the sandbox, and we saw how we're using the data that comes from the server to actually create entities, which means that the title, the alias, the description, privacy, those are just values, right? But the modules, we are converting them into actual modules. Maybe we should call it, let's rename this to sandbox module. Like that. And then we'll have to change that here. Let's see. This is not create sandbox module. Type of sandbox module. Sandbox module. Sandbox module. And sandbox module. Okay, so now we have an array of modules. And let's see, where's the Codesandbox client? We have a bunch of other stuff on the sandbox, and let's just go through it because I really want this to actually run at some point. So let's have a look at what's left on this iSandbox DTO. Is there some effective way I can do that? Oops. Let's just take a look at it. Oh, iSandbox DTO. Okay, so we have. Maybe we can just copy it all over. Oh my god, there's so much stuff. Okay, but we have to do this. I wish I could kind of balance it so it would be more interesting. It's kind of boring to just see me implement all these properties. But we kind of have to. Let's take a look. Let's just go through them. Maybe we can rather talk about them. So we have directories. So yeah, well, I guess. Yeah, so a directory should also be its own entity. Oh, this is interesting because when I refactor this now. Oh, has the listener stopped? Oh no, I didn't save it, sorry. Create sandbox module. Sandbox module. There we go. There we have the link back. Okay. So directories are also entities in the database, which means that those should also be like a feature. And then we have like npm registries, that's just data, feature flags, just data, collection, just data, owned, authorization, npm dependencies, custom template. Those are probably also just data, fork template sandbox, external resources, team, room ID, author. Yeah, so all of this is just, it's like static data. We're actually not going to do anything with that data. But I do find, like, one thing I find interesting is when we have, there's tons of data here, but some of it is actually related to specific concepts. So for example, Git, that's like a feature of the, yeah, so maybe we could take a look at that. Let's not look at all these static properties. That's just boring. I can rather fix that later. But let's do with the dynamic stuff. So let's implement directories. Directories should be sandbox directory, an array. So that will work the same way. Let's just save that and add that as a feature. Sandbox directory should be a factory. It should be, wait, there's something wrong here. Why isn't this? This linking stuff. It's kind of annoying. So when I rename this, it seems that it lost its link. Oh, maybe I don't have this linking logic on renaming. Okay, let's just refresh. There we go. Okay, so I need to fix that. But anyways, we also have a sandbox directory, and that also needs the sandbox API to make updates to the directories. And then it's going to be linked here. What the hell happened now? Now it lost this link. What the fuck? Oh my god. I have to seriously consider a different approach to keeping these links in sync. Let's see. And I think we probably should move these like that, so it doesn't keep bumping that thing away. Yeah, this is interesting. Why are those links so difficult to keep in check? You see that? It's supposed to be a link from Sandbox API down here. Let's move these a little bit again so we get a better view. Okay, cool. It's kind of, yeah, so one thing I was thinking about, I saw this tweet about XState, and there is work on a UI editor for XState. Though you can imagine like something like Codesandbox to be built with XState. Like it's technically possible, but there are two very difficult things there. One thing is in terms of UI, you can imagine inside the editor, inside the navigator, inside auth, we have state machines, which has several states. So you can imagine those being individual nodes as well. And there will be several more state machines there. So you can imagine like this, we're already seeing a lot of complexity here, but that complexity would just be increased as it's like lower level. So I wonder how they're going to solve that. If it's like you have two layers, maybe you have one layer being like only the machines, and then you can like dive into a single machine and then you see the transitions in that machine. So you kind of have these two levels. I think they have to do that to make it work. So you can, at like the machine level, you can see what machines actually are related to each other, are like children of each other. Because that's also a thing. Yeah, and also like how do you express creating multiple machines, like factories of machines? Yeah, so I'm very curious when they're done with that, because they certainly do have some challenges. But yeah, that's what I like about, if you want to see how things are tied together, doing like a dependency graph, I guess that's what we can call this, is more appealing. It can handle a larger degree of complexity, I think. That's kind of what we're exploring here. Okay. But let's see, where were we? Yeah, I have to look into the links. But we, yeah, sorry. And then the second thing, the second complexity of, oh, now I forgot. I thought about two things. Oh, was it the factories? Yeah, I think it was the factories I meant to talk about. Anyways, let's see. So we have our sandbox directory. Let's look at the code for that. And we have sandbox directory, and I guess, yeah, we don't really need anything more than that. Cool. And then we have the Git stuff. So this is interesting. We have a ton of data on a sandbox. We also have like a team, which is also interesting. I'm not sure like what you can do specifically to a team. I'm not sure if it makes sense to do anything about that, but Git certainly makes a ton of sense to do something about. Let's see, tags, environmental, source ID, source, template, and also the template, I think. Because you can update the template. Maybe, but at least Git. So we can add Git here. And what I mean is that we won't expose these properties on the sandbox itself. We will rather expose a Git feature. And that feature will hold all the logic for dealing with Git. So let's explore that. Save this. Let's create the Git feature. And that's a complex feature, OMG. I talked about this before, but the initial Git-like implementation of Codesandbox was basically just to have the possibility to copy a GitHub URL, paste it into Codesandbox, and see the code running. And then like fork it and change it and stuff like that. But then we wanted to make it possible to actually contribute back to the repo from Codesandbox. And the way Codesandbox stores its files, like a sandbox stores its files, you see here you have like modules and directories. And then you have especially binary files. So Codesandbox uploads files to other services. It's not actually stored in the database. And that causes a lot of complexity because on Git you actually have the binary in Git, but in a sandbox you have a link to an image, and that link is different based on you having a private or a public repo. And then we have to find ways to figure out if the images has changed based on the binary, but we have to convert it to a URL. And then if you add an image to the sandbox, we have to upload the binary to Git, but it's still a URL in the sandbox, and it's super, super complex. It got to the level where it doesn't, like, it works relatively well, but yeah, Codesandbox is going to get proper Git implementation. But it's a lot more work than you might think, because now we're using the GitHub API. Anyways, I'm digressing. Let's add it's a GitHub feature, so let's call it GitHub. GitHub, it's a feature and it's a factory because we need to create one specifically for a sandbox. And it is actually only there if there's actually Git related data. So what we can do first is, we can tie it to the sandbox so it's able to create it. And then this would have its own, it requires its own API, which is a new feature. And it actually uses the REST API. So all the calls to GitHub goes through our server, through the REST API. So let's call it GitHub API. And it needs the REST API currently. And let's tie that into, this is kind of fun, tying this stuff together. Okay, cool. So now we have a GitHub feature. Yes. And by the way, these directories are going to be observable. Cool. Nice. So what we would need to do here, first of all, let's look at this thing to see what kind of data do we want to pass into this constructor. And to do that, we need to look at the types, and we see original Git, base Git, PR number, original Git commit SHA, base Git commit SHA, original Git changes. All of this stuff we really want to pass into the GitHub feature. And I guess we just have to pass it as data. I guess we can just call it get data. So what's interesting about this is that we will always have original Git in this case. That's kind of what defines if it's there. So it's not null in this case. I don't remember if we always have a base Git. If we have, no, we don't necessarily have a base Git. That's related to PRs. Original Git commit SHA, we always have that. We don't necessarily have a base Git commit SHA. Oh, did I remove it? Sorry, I wasn't supposed to remove it. We might not have a PR number. Original Git commit SHA, we always have that. We don't necessarily have that. And we always have, we can say that we, do we ever pass this in? This is interesting. We don't need to pass this in actually. Oh, this is interesting. This actually cleans up a little bit. Right. Okay, so to actually get these original Git changes, yeah, it seems like this needs to be a state machine. The reason I'm saying that is because, first of all, we have to fetch some data. So it's not really ready when we create it, which is good enough reason to make it a state machine, because some state is only available in certain states, even if it's just 2 states. But we also have this addition that it might be a PR or it might not be a PR. So there are actually 3 states here, which makes it a really good candidate for a state machine. So I think we should just do that immediately. Yes. Yeah, and I think maybe we have gotten to a point now where I can actually demo this inside Codesandbox, because it would be really interesting to implement this GitHub feature. So kind of show all of this stuff as kind of, okay, this is what Codesandbox would look like. And yeah, I think we have demos on Friday. Yeah, I would like to demo this. And then I will implement the GitHub feature and show how we're actually able to split up things. Okay, but let's just implement this as a state machine now, just to take a look at it. And then I'll kind of redo that in the demo on Friday, I think. Cool. Okay, state machine. Let's go back to it. So the states we have here is loading. We have, what should we call this? If it's not a PR, direct, or it's a PR. And we'll look at the event soon. So when it's loading, it's just loading. When we have a direct connection, like not a PR, we have original Git. We have original Git commit SHA. Yeah, that's basically it. And we have the same if we have a PR, because we use that for comparison. But we also have a PR number. And we have a base commit SHA. Oh, base Git and base Git commit SHA. Oh my god. And base Git commit SHA. Okay, oops. And now we don't need these null things because we know we actually have them. And this is what state machines do. They actually get rid of these strict null checks or strict null checks issues. You really do like, maybe I have it. You always have it because you tie it to an explicit state, which is super nice. And then, yeah, and original git changes. Let's see. You have those also in, okay, so let's, we need to create a type here. Type base git, no, again, base default state or default context would be, oh, what do we call that? Original git changes. Oh, god damn it. Did I remove that? Original git changes. Original git changes. Cool. We have that in the default context, and we also have these two things in the default context. And then we could just say it's that and the default context. And this one has this stuff and the default context. Cool. Yes. Cool. So that means when we start off here, we are loading, and then we have the different events. So we have yeah, what are we actually loading? I can't remember. What are we actually loading when we open the git thingy? I think we're getting the changes. Okay, sync. Well, sync is a bad word. Well, the word isn't bad, but it doesn't fit in this case. Okay, we kind of have to dive into this thing to see what it actually does. So let's just keep it as foo for now. Oh, didn't I change? Let's change this to use the transition thing. Where are we? Oops, reactive app. Where are you? Files manager. Is this where you're at? No, it's is it here? Files manager. Yeah, here we are. Switch. I'm thinking that we'll rather use the. We don't need a return type. We can rather say. Return this transition, this context event, and then we say foo bar. Let's remove this, and then what was that? Something happened. That means we'll move into state bar. If something happened here, we move into the state foo. I'd rather want to show this API. Anyways, where were we? Okay, so how are we going to get through this? At least we're going to return this transition, and we don't need this because this transition actually has the return type. So if we're loading, if we are on direct, and if we are on PR, I think we need more states here, but we'll look at that later. This is actually quite a complex feature. But anyways, so how are we going to deal with this? So our context here, I haven't fixed the order of the properties yet. So it is loading, and then we need to, what do we need to do? I guess I think we yeah, I have to check. We have to make an API. Well, let's take a look at it. The Git feature, GraphQL overmind effects. Well, not effects, namespaces, Git, and I think we have like, yeah, of course we need to. This is how we do comparisons. We're loading the Git source. Then we're getting the permissions, we're comparing it with the source, we're comparing it with the base depending on the state. Yeah, because you might be in conflict, and yeah, there are tons of different states here we need to go through. We don't have to go through all of it now. Our goal was kind of to see how we could model this, how we could split it up, which we kind of explored now. But anyways, the initial one is loading because we do need to download all the comparison and stuff. And we do need all of this, where original Git is definitely there. Oh, base Git is not necessarily there when we pass it in. Because this is what we check. We'd like, do we have an original Git? And if we do, we have a GitHub link, and we can create this thing, so it will be there. This thing is actually optional, I think. Original Git, yeah. So I guess we'll just check both of these. And then these are like optional. They might be there or might not be there. Yeah, you kind of see why we have strict null check issues. Cool. So ideally on the server we would actually just have a Git property, and that would hold all this stuff. That would be more ideal, because these are like tied together. If one of them is defined, the other one is also defined. But in the typing, they're not necessarily that way. It's interesting. Anyways, so we have our data here. So let's go back to our sandbox. And then we are going to do a check here. If sandbox DTO original Git and sandbox DTO original Git commit SHA, then we are going to we're going to call it GitHub here. And this is going to be type of GitHub. Yes. And then we're going to say this GitHub equals this create GitHub. And then we need to pass in, let's see, original Git. And now it knows that it's there, so we shouldn't get any typing issues on that. Original Git commit SHA, sandbox DTO, Git commit SHA. And I'm not sure why we're getting original Git changes, because those are actually produced by the client. So I'm not sure why those are there. But anyway, sandbox DTO, Git. Where are we? Base Git, sorry. base git commit SHA, oops, and then we had PR number, sandbox dto.pr number. Cool. So it's happy about that. That's good. But this is nice. So now we have, yeah, and this might not be there. So we have to do like that. Nice. Cool. Okay, I actually, how much time do we spend now? Yeah, 30 minutes. This is what I really want to do, like spend 30 minutes. We've been going for over an hour a couple of times. But yes, so this was a really interesting thing. And as I said, I just realized that we have enough now that I can actually start demoing this internally at Codesandbox. Because I'm trying to think how we can actually move towards a concept like this, and it's just important. And like the question is, why is Overmind limiting here? And it's just the nature of having a single state tree. Maybe I should write an article about this. Sorry about the background noise, by the way. Someone's awake. Yeah, write an article about single state trees, typing, and co-location of logic. What challenges though that brings? Because it's a very straightforward and appealing concept to have a single state tree, and like in Overmind, it's even an observable state tree. And then you kind of just write the logic next to it. But it just can't, that kind of concept can't deal with this kind of, yeah, like how would you make the logic asynchronously safe? Like you really can't, because you have to tie the logic to the context. But in a single state tree world, the logic, like every single piece of logic, every function, it being a thunk or an action or whatever it is, it doesn't know about its context. So you can run it at any point in time, and you would basically have to write a ton of checks all the time to figure out if it can run or not. So in yeah, this is interesting. So in Overmind, you do have state machines. Oh yeah, using state machines. Blah, blah, blah. Current. You do have state machines to protect the state itself, but it's not like the logic isn't part of that context, so you have to do all these checks to see if you actually can run the logic or not, which is okay. Like you can't do any better in that world because of the decoupling, but when it's tied together, you can actually start to express it a little bit better. So an example of that would be, where do we have, I guess we can look, oh, not auth API, but auth. So you have like sign in, and then you can just send, you can just do the thing. Like you can expose an API, you can just do the thing, and then you have this mapping that ensures that you can actually run it or not. Yeah, it's interesting. Yeah. Anyway, so there's like two parts to why I'm exploring this. It's to be able to more effectively write state machines by co-locating logic and state, which also helps you deal with asynchronous logic. So for example, also in Overmind and Redux and these kinds of single state tree solutions with the coupled logic, you can't like block asynchronicity, meaning that if you start some asynchronous process in an action func, whatever, you manually have to check every time you do something asynchronous if you can actually continue working. Like you have to manually check the context that you're in. Can I continue running this logic? And I guess we kind of made that work pretty well in regarding a base state. Yeah, nesting. Do we have any? Do we have any good example of that? Yeah, this is kind of interesting. We could actually improve this API. Yeah. Anyways, oh, sorry, I'm completely inside my own head now. Do we have any? Do we have any good example of what I'm trying to talk about? I guess we don't have that. So for, yeah, I guess here. Yeah, so this is what you kind of have to do. You first, in an action, you have to explicitly express, okay, are we in a context where I want to actually run this logic? And then you do something asynchronous. And then you have to check again, am I still in this state? And then let's do something about it. So that's kind of what you don't have to do if you co-locate the logic with the state. Then you can always just send whatever you want to send. Oh, wait, sorry. Yes, sorry. That was partly true. Because in this case, yeah, okay, now I know how to explain it. So the thing is, when you don't I'm kind of building up for an article here. So when you decouple the logic doesn't know anything about the nested behavior of the app, because everything's at the top, right? Because you're not co-locating the state and the logic, which means that in this case, we have this root level action that wants to actually do something to the nested to-dos. Like to-dos is nested within the authentication, because the to-dos is only available when you're actually authenticated, right? So to be able to do that, you have to, first of all, no matter, you have to check manually if am I in a state where I want to deal with this logic. And then after you do something asynchronous, you have lost your context, which means that you would have to check, am I in the authenticated state to get access to the to-dos, and then you'll send the event about the to-dos being loaded. But in a world with co-located logic and state, you wouldn't do any of this. You would basically just send to, let's see, user and signed in. Well, you would basically just point to the auth and say sign in, and it would send to itself, just send. It didn't have to check user or anything. It would just send to itself signed in. And then that would actually trigger getting the to-dos. And then since it already knows that it's in that context, this is really hard to explain, but this is a really great example for an article. Take this piece of logic and see how would this look like if you had co-located state and logic. That's my point. Yeah, but this is great. I'm going to write that article. And then also bring up strict null checking. Yes. Anyways, sorry, I was all in my head there, but thanks for following along. I hope this makes sense what I'm doing here. It's really about exploring how would like all of Codesandbox look like in a tool like this. And it will be like a lot of information, but the point is that this abstraction of information is way better than looking into files and directories. That's the whole point. Yes. Okay, good. Sorry. We'll talk more tomorrow. I'm not sure what we're going to do then, if we're going to actually implement more of the GitHub thing, or maybe we'll explore something else. Maybe we'll go back to the navigator and start adding some more stuff. We'll probably do that because I don't want to go too far into the different parts, because it's a ton of work to implement each part of this and it might be a little bit boring. But let's move back to the navigator tomorrow, and then I will again save this GitHub thing for the internal demo to show how we would actually add a feature, as if we didn't have like the GitHub thing. Cool. Okay, bye for now.